For this example, we would like to find the distance between the order pairs 6, -1 and 9, 5. We are going to give the answer in both exact form and as a decimal rounded to the nearest thousandth. To do this, I will first write my order pairs and label them. The first order pair I will label as x sub 1 and y sub 1, meaning the x from the first point and the y from the first point. The second ordered pair I will label as x sub 2 and y sub 2, meaning the x from the second point and the y from the second point. This gives us a way to keep track of which x and y are which. Then I will use my distance formula. I encourage you to write down the distance formula each time you use this, and it will make it easier to remember when you take a test. The distance formula is d equals square root of x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared. I will then plug the x and y values in as I have them labeled above. X sub 2 is 9. Be careful, the formula has a built-in negative, and sometimes when your numbers are also negative, this can cause confusion. My x sub 1 is 6. I will square that quantity, add, and then y sub 2 is 5 minus a negative 1, I'll put the negative 1 in parentheses, and then quantity squared. From this point, simplify the values that you're subtracting. 9 minus 6 would result in 3. Keep the square. 5 minus negative 1 is really the same thing as 5 plus 1 squared. And then from here, 3 squared is 9. 5 plus 1 is 6. Keep the square. Keep the 9. 6 squared is 36. And then 9 plus 36 is 45. Now, it wanted the answer in exact form. This is exact, however, it is not simplified. For square roots, you want to factor the value that's under the root to see if any factors are perfect squares. In this case, we could factor 45 as the perfect square 9, perfect square meaning that there are two other numbers that are the same that multiply to it, so 9 would be 3 times 3, and then the value 5. So 9 times 5 is 45. 9 is what we call a perfect square, meaning that it has a root. So rewriting in this way, I can write it as 9 times 5, and then we can take the square root of 9, which is 3, pull that out from under the root, and then the 5 does not have a perfect square, so that's left underneath the root. Notice that 5 is a prime number, meaning that the only factorization for it is 5 and 1. Because it can no longer factor as perfect squares, then we know that this is simplified completely. So this would be my exact answer. For the decimal, you will want to go to your calculator. You can do this one of two ways. You can either type in 3 square roots of 5. I would say the safer thing to do in case there was an error somewhere in these steps is just to type in square root of 45. Your root button is found by pressing the second key and then the x squared button. That will yield your square root button, and then you can type in 45, press enter, and then that will yield your answer as an approximate value. So here, this would be 6.70820393 632. They wanted the answer rounded to the nearest thousandth. The thousandths place would be here. The value to the right is a 2, which means that that would stay in 8. So 6.708 would be the approximate answer rounded to the nearest thousandth.